Hello everyone and welcome to this new video of Everyday JavaScript. In this video, we are going to look into what are the new features of Angular 9. The new and the latest version is Angular 9.1.6. So let's get started.
Before I start this video, please like, subscribe, and share this video with your friends. And also don't forget to comment in the comment section. Thank you.
We're going to discuss the new features which are at the core of this new release. Now, there are several features that have been released with Angular 9 and we're going to discuss them one by one. The main feature of Angular 9 that has been released under the hood is EV. The main feature and the one big feature in Angular 9 is EV. It was shipped in Angular 8, but it was optional. The default rendering engine in Angular 8 was Vue Engine with an option to turn on the EV rendering engine. In case you don't know what EV is, it's their new internal rendering engine, which means that it's the logic behind your entire Angular application. Now, we write a lot of stuff inside our Angular application like ngIf, ngFor, the directives, the pipes, the components which are the combination of HTML, styles, and TypeScript, the templates that we are writing. Basically, all the logic that you write, EV compiles it down into a lower level language, which is more close to like native DOM functions. Like let's say if you had to create an element, so EV writes such kind of functions. What Vue Engine used to do is totally opposite. Vue Engine was a plethora of switch cases for each and every element that you write inside your template. Now, Vue Engine was something like switch case 1, does this element have ngIf? Switch case 2, does this element have ngFor? Switch case 3, does this element have an event binding? And hence execute this. Because of this, the execution time and the compile time in Vue Engine used to be larger, and hence the EV engine, which is more direct way of writing the logic, is much more faster. It's an under the hood change, and it means that the contract or the API with which you are writing Angular application does not change. The thing that you had already learned in Angular 8 remains the same. You don't need to unlearn Angular 8 and relearn Angular 9. Everything that you had learned remains still valid and relevant. What is cooler about this new rendering engine is it is already offering smaller bundle sizes. For small apps, for medium size apps, and even for larger apps, there is a significant size improvement. Smaller bundles means less code to be downloaded inside your browser, and hence it means it's faster to execute and performance is increased. Another good change that has happened is you build and serve your application with AOT, ahead of time compilation. Angular 8 with Vue Engine used to do this with just in time compilation, JIT. Now, what's the difference between AOT and JIT? AOT means your errors would be more compile time errors rather than runtime errors. You will get fewer surprises or fewer shocks when you run your code in your production or when you execute your code inside your browser. You'll get most of the errors in your compile time, which is quite great because rather than having production time or runtime surprises, it's better to have a compile time surprise. This chart shows you the bundle size comparison with Angular 8 Vue Engine. EV gives us a significant size improvement in small apps, medium size apps, and larger apps. We are going to discuss more about EV engine in three questions. Why do we need a new engine? How does it work? And how to use it? So let's start with why do we need a new engine? Angular has a history of changing the rendering engines. Initially, when we had Angular 1.x and Angular 2, it used template engine. Then from Angular 4 to Angular 7 or Angular 8, it used Vue engine. And now it is using EV engine. And EV provides such kind of important modification and optimization in your bundles that we may be even able to do away with ng modules altogether. Now, every one of us knows what ng modules is. A module which is a combination of, let's say, components, services, etc., etc. Let me ask you one of the most important questions. What is the most costliest resource in the website? It's definitely not HTML, it's definitely not CSS. It's JavaScript. The bundle size and the parsing and the execution that takes place inside your code is mostly done by JavaScript. And sometimes this JavaScript can go in size of MBs, which is not great. And hence, reduction of this should be our prime focus for a good application, good front end application. If your bundle sizes are lower, your applications would be performing well. Let's look at why someone would use EV rendering engine. There are three main reasons: smaller bundle size, faster compilation, and it's easier to debug. Let's go ahead and check each and every point one by one. We've already seen smaller bundle sizes and faster compilation. Let's see how does it do those things. And we are going to answer it. How does EV help us achieve smaller bundle size and faster compilation? View engine, what it used to do is whenever it used to encounter a component, now let's say I have taken an example of cat component over here on the left side. The component consists of TypeScript, style, and the template. View engine used to compile it into two separate files. One of them was cat.component.js, which was the compilation of cat.component.ts, and the second one was cat.component.ngfactory.js. This ngfactory was the compilation of your template, the HTML file, and the template bindings or the directives that have been used inside it into a view engine code. That means that view engine used to generate two different files. That means the bundle size was larger. Also, the compilation was slower because it had to generate two different files. Another reason why the bundle size was larger is the reason why I said view engine is producing so much amount of code. It used to have plethora of switch cases for each and every element that it used to detect in the HTML template. So let's say it detected the first element div. It used to go ahead and check every condition inside it. Like let's say, does this div have ngIf? Does this div have ngFor? Does this div have etc. etc. Event binding, etc. All those switch cases. I'm just giving an example, a rough example. So for each and every element encountered in HTML, the view engine used to have this lots and lots of switch cases, and hence the bundle size used to increase, and the compilation was also slower because lots of switch cases. That means it's a kind of like a code smell, not a good code. EV, on the other hand, same cat component is now compiled into a single file, cat.component.js. This JS is a combination of the compiled form of your TypeScript as well as the ng factory that was generated. But it's different. The ng factory that is generated is way more direct than what View Engine used to generate. EV under the hood has more close API functions than what View Engine used to have. Remember, View Engine used to have lots and lots of switch cases, but now EV has direct API functions to create the element and to insert the template bindings or to insert the string interpolations that you used to have. Let's go ahead and look how EV engine compiles your code. Now I've created a component on the left hand side. You can see home component, and on the right hand side you can see the TypeScript of it. Inside the component class, I have a title variable which is of string type, which says it's a home component. And on the left hand side in the template, I have the title binding over here. Now you see the structure over here of the home component. It's a div with a class card. Inside this we have a header and content divs, and inside the header div we have a h1 tag which is having title string interpolation. Now let's see how EV compiles the code into a lower level language. This is the compilation of your EV code. Now if you go ahead and see how the EV compiles your code, it's quite simple. It says there is a function named element start. So it starts the div element, then another element, then it says create another element inside that which is of name h1 and insert a text node inside it. The text that we are seeing over here as title. and then you can end the element, you can close the element tag, and then you create a new element and end the element. So the structure and the compilation is much more direct over here as compared to what View Engine used to do. And there are two sections in EV which takes care of it. First one is creation of the template, that is these direct functions which are much more closer and much more lower level in the DOM. And the second one is updation of the template. We need to update the template as well with the title value. So what it does over here is it targets the text node that it had been created, and then it interpolates with the current value of the title, that is home component. So that's why the EV's bundle size is quite small, and the compilation is much more faster as compared to View Engine. Over here, I've explained or I've tried to show what View Engine does. The compilation is much more complex, and there are lots and lots of functions apart from this. So let's go ahead and look at what View Engine compilation is. So here's the compilation of View Engine code. As you can see, there are lots and lots of functions that get called for one single component definition. And that means that we are doing so much amount of work that is not at all necessary as compared to EV, which was much more direct. The View Engine is doing lots and lots of stuff that need not be done. So the function calls are mentioned over here, and the function definition, which are long, very, very long, are mentioned over here. So that means that View Engine is doing lots and lots of stuff which need not be done at all. Another reason why EV Engine is giving us smaller builds is we don't pay for the framework features that we don't use. It uses the concept that is known as tree shaking. Now, what is tree shaking? Tree shaking is where we don't ship anything inside our browser that is not being used. Let's say my component is using only the A feature of our module, and that module exports A, B, and C. That means that I am not using B and C feature of the module, and still it used to be compiled and bundled inside my View Engine. But with EV, what happens is if I am using only A part of the module, B and C will not be bundled, and hence my bundle sizes would be smaller. Another important feature of EV is it is easier to debug. The stack tracing errors is way more better as compared to View Engine was. We can get more detailed error messages and more helpful error messages, which will help us in faster development process. Another thing that is possible over here is debugging of the template is now possible without using the debug points. Let's see how the stack tracing errors are improved. So here you can see the comparison of View Engine errors and the EV errors. So over here, I don't know which component the error is. But if the error is throwing up from a template, a component which is not existing, EV would go ahead and just simply point out where the error is happening. And it will also tell the source of the error. Like let's say the app component was having a non-existing component, and that is the reason where you're getting the error. It is much more helpful than the above error message. Second thing is you get more better stack traces and more helpful stack traces as compared to what you used to get in View Engine. And they are much more helpful, and you get much more details in the stack trace and clearer details over here. Now let's see how we can do debugging at runtime without putting the debugging. That would be something great. So EV provides us with a global level object like window and document used to have a JavaScript. You now get ng as a global level object. Let's see. So what I've done is, here is my Angular 9 application. Let me run this application. Now let's go ahead and check our application. It's running already on localhost 4200. I'll just go ahead and right click inspect. I'll go to the console and see over here I have ng available as a global object. Now I'll go to the elements tab And I'll just go ahead and select the app home component, which is our first component that gets loaded inside our router. And you can see over here $0, it is coming up over here $0. Let's go ahead and try and access this. Let my component equal to ng dot get component $0. Now let's console my component, and I get home component instance over here, and that too without having to put a debugging point. Now let's try and change the title of this home component. Let's say my component dot title equal to new title. Now let's change the title of the component to new title. So I'll just go ahead and press enter, and the title is changed. But our changes are not reflected over here. So let's try and see how we can do that. So now the title has changed, but the changes have not yet reflected. How will it reflect? We got apply changes. My So over here you see the title has changed, and I can access all the event listeners. I can access all the functions of this component, private, public functions, everything. And you can just imagine without having to put a debug point, how easy it is to debug a component inside Angular. So that's how the debugging has improved inside Angular as well. So that means debugging at runtime has become much more fun. You can ask Angular for access to instances of your component, directives, and much more. You can manually call methods, you can update the state of your component, and when you want to see the results of change detection, you can just trigger detect changes or ng apply changes. So this is what we had done. We see $0 besides a component, and you can target this particular component by using $0. And this is how we access the component, and this is how we change the title of the component. We have so many options with ng, which we can't wait for you to explore. Like, let's say, apply changes, get component, get context, get directives. You can get the o-ring component, you can get the root component of your current component, and lots more. You can do anything with this thing. It's like a full-fledged debugger without having to put a debugging point. The last thing about EV that I wanted to say is usage. How would you use it? Actually, all you need to do is, if you are in Angular 8, you just need to go to tsconfig.json and write enable EV to true. But if you're using Angular 9, you don't even need to do this thing. It's enabled by default. The only thing that you can do is fall back to view engine if you are facing some issues, and we would like, or we would encourage you to go ahead and report those issues on Angular GitHub page. So for Angular 9, it's enabled by default. You don't need to write anything in tsconfig.json. If you are in Angular 8, you need to write enable EV true. The next thing in Angular, the next thing in EV is AOT has to be true. By default, it comes as true, but if you are in Angular 8, you can just turn it on to true inside your angular.json. The recommended browser list, I've mentioned it over here. It's totally optional. You can have your custom browser list over here, and you can also have the browser list if you want or don't want differential loading. So you can customize this thing based on what you want or don't want. Inside package.json, this is a helpful tip from Webpack. You can turn off side effects. Side effects as false. Now this will give you a tree shaking feature of Webpack, which will be very helpful, and which will help you in reducing the bundle size further. This is not an Angular 9 feature, but it's something that is recommended. Next thing that I would like to talk about in Angular 9 is lazy components. This is something an exciting feature that we are looking forward to, and it is something that will help to reduce the bundle sizes drastically. Now, till now, we are under an assumption that only modules can be lazily loaded. But using ES6 import syntax, we can now load the components as well using lazy loading. How? Let's go ahead and look it. So I've switched back to my Angular application, and what I'm going to show you is my source code. So I have a home component over here, and inside this home component, I've added a button which is simply add component, and I've created a container lazy component, and I've created a container lazy component. Now, what I'm going to do is lazily load upon click of this button. I'm going to lazily load this component, the lazy component, upon click of this button inside this container. We're going to use view container reference. And how are we going to do that? What is this lazy component? This lazy component is a simple div which has message inside it and some interpolation which is randomly generated message ID over here. So this is a simple component that I wish to load on click of a button inside this div. Remember, this component will not be packaged with your main.js. It is going to be lazily loaded. So on click of this, I have created an add component function. So I'll go to add component function. What happens is using the ES6 import syntax. This is an ES6 import syntax. I'm going to refer to the lazy component. Now this component is referred, and as soon as it is loaded inside your browser, then what happens is you get a promise action. This promise action will give you access to the lazy component. That means that whatever the things that have been lazily loaded as a part of this file is available inside M. I'm accessing the lazy component inside M, and then using the component factory resolver, I'm going to resolve the component. I'm going to get the access to the factory of the component. That is the template. Next thing that I'm going to do is I'm going to create the component. And for creation of this component, what I need is I need access to which place this component needs to be created. So I'm going to say this dot view container ref, which is nothing but a reference to this div element, this lazy component. And I call create component inside it. I pass the factory and I use the injector and I create a component. Now let's go ahead and run this component. For this, I'm going to keep the network tab open and I'm going to go in the JS section so that we can see all the JavaScript that is getting lazily loaded over here. So as soon as I click add component, a JavaScript should be loaded inside this. So you see lazy component being loaded over here. If you're not able to see, I'll just increase this. So are you able to see the lazy component being loaded over here? And if I load it again and again, this component does not get loaded every single time. It will be loaded only once. It will not be loaded again and again. So it is loaded only once and it is lazily loaded. It is not part of our main.js that is bundled at the beginning.
So this is one of the most important features, lazy components. Now let's continue. This term in future is going to be known as locality. So keep in mind whenever you come across this term, you will get to know that this term is known as locality. We also have faster testing. Now the changes that have been done is we often use before each inside our Angular unit test cases, and we use testbed.create component. Now what happens is previously the test bed used to compile the component every single time before the unit test cases, irrespective of whether the component has changed or not, the component instance has changed or not. Now, with Angular 9, the test bed would only be compiling the component only if the instance of the component has changed. So there would be faster execution of the unit test cases. The next feature that we have is stricter type checks. That means that we can't be lazy developers now. We don't have any more options of phantom variables that we used to declare on the fly on the template. Now let's take this for an example. Let's say this div was an element of a particular component. Some developers used to declare or manipulate the value of the variables just like this on the template itself. Now it will throw an error, and it will also throw an error if there is a missing variable in the template and that variable is not present inside the class. So that means that we have an option of stricter type checking on Angular 9. How and what all options are present? We have three different modes. The basic mode, which I don't recommend, where you set full template type check to false. I don't recommend it at all. Over here, what happens is it's a very basic type checking. If I were to give an example, like let's say if map was a component and city was one of the attributes to be passed to this map component, then it would just go ahead and check whether user is an object, user.address is an object, and user.address.city is present or not. But it will never go ahead and check whether this value of whatever type it is it assignable to this or not. It will give you a runtime error rather than a compile time error. That means that you understand the frustration. This error, which could have been caught on compile time, is now appearing on runtime and possibly may appear on production. The basic mode does not even check on the ng templates or the ngif or ng4, the embedded templates inside your component. So it does not check inside those things. Whereas in full mode, it does check inside those embedded templates, but it still misses out on dollar event or output events or input variables, all such stuff. It also does not check the pipe return type or directive return type. Strict mode, which is recommended, I would like you to go ahead and check this inside this page, inside Angular. This is the Angular template type checking. I would recommend you to go ahead and check this page for strict mode. It gives you a lot of options for strict mode. And guys, this is going to be way more helpful and useful in reducing the production errors. So I would recommend you to go ahead and check this template type checking, and especially the strict type checking mode. And I would recommend you to turn it on. So that is the strict type checking that you're going to have. And next thing that we are going to have is this is an example of what all things you can get with type checking. So you can get whether the pipe is getting the required data type or not. You can also have TypeScript kind of checking, like let's say that on a string variable you don't have a function starts with, so it will throw an error that start with does not exist on type string. These kind of errors, if they are appearing on production, I think there's a lot of effort that goes on production deployment. So if these kind of errors appear, it's like kind of like waste of an effort. So we can avoid it if we turn on the strict template type checking to true. We can also disable some places the template type checking if we are in a dead end, like we don't know the data type of this. Then we can use $any and we can get away with the problem that we are going to face. Because of this, many of the errors are going to become compile time errors as compared to runtime errors. So that is much more helpful in order to reduce the production errors. Built-in components, I won't talk much about it. We have now YouTube player component and Google Map component, which is available to integrate with your application, and some of the simple use cases can be achieved easily with these components. And we have improved CSS and style binding. Now what earlier used to happen is there was no particular sequence in which the Angular used to apply the styles to your component or elements inside the component. So let's take an example, like let's say we have my component over here and there are three styles being applied. What used to happen is the sequence of execution, like this used to be executed first, this used to be executed second, and this used to be executed third. So if my color and my other color used to be undefined, still, this is going to be the third one that to be executed. It was going to ignore this particular thing because this is the last one to be executed. And whatever the color over here is, it is going to take place. There was no particular priority defined over here. But now with Angular, you have much more clearer priority defined. um, let's say style.color takes much more precedence than style because it's much more specific as compared to this. One last thing that I'm going to talk about is services. Now you remember, for creation of singleton services we used to write provided in inside the @injector annotation, and we used to write root. Now we have additional two options, platform and any. Root used to be used for singleton instances of the services to be created across a module. Platform will be used for creation of singleton instances across multiple applications on that page. So you have, let's say, multiple Angular applications or multiple Angular modules loaded. You can use provided in platform and it will create a singleton instance of a service for all those applications. And any will create a new instance for all of the services that you are injecting or wherever the service is getting injected. Null behaves similar to any. So by default, it is any. So all these are the options for provided in service. So that's it for Angular 9 new features. I hope you like it. So please do like, subscribe, and share Everyday JavaScript and share it with your friends. And please do let me know in the comment section if any new features of Angular 9 that you want to understand inside this comment section. Do subscribe Everyday JavaScript. Thank you. I hope you enjoyed this video. For more videos like this, please like, subscribe, and share my channel Everyday JavaScript. And for any other concepts that you want me to explain visually, please drop your comments in the comments section. And thank you for watching.